So when rocks are put under an immense amount of stress, there's two ways that they can respond, and there's two ways that they can deform. One way is called the one way is called plastic deformation. Now, plastic deformation, I'm going to use my Play-Doh here as an example of plastic deformation. So I've got some Play-Doh. Right now the Play-Doh is at rest. There's no stress being put on it. But if I start bending and molding this Play-Doh and start putting it into the shape I want it to be, I'm putting it through an immense amount of stress. Well, what's nice about Play-Doh is Play-Doh doesn't, it bends very easily. It's very flexible. It can bend, it can buckle without a problem. So it really doesn't show any signs of building up any kind of stress because it's kind of going with the flow. That's an example of plastic deformation. When it's molding like clay, that's an example of plastic deformation. The other type of deformation, which does put stress on rocks, and rocks do respond negatively, is called elastic rebound or elastic deformation. So elastic deformation, the example I can give you is think of a rubber band. So I, again, have a rubber band here. Now again, the rubber band is at rest. I'm putting no stress on it whatsoever. Now let's imagine, if we will, that my hands are plates. And the rubber band represents a rock stuck between plates. Now, a rubber band, I can pull, if I put stress on it, it means I'm pulling at both ends of it. I'm stretching this rubber band out as far as I can. Now, if I keep going, what's going to happen? You're right, it's going to snap me in the hand, it's going to hurt, leave a nice little welt. I'm obviously not going to do that. However, if I represent my hand as two plates, and let's say I do a transform boundaries when the plates slide past each other. If a rock gets caught between them, watch what the rubber band does. That's the rock between them. It's being put through an immense amount of stress as these plates move and shift and move and shift and move and shift. Okay? Now, when a rubber band breaks, it's going to snap. And what that snap does, it's going to release energy. It's going to try and push the rubber band back to its original form. When it does that, it gives it an immense amount of energy that is moving at a really great rate of speed. That's why when the rubber smacks into my hand, if I was going to actually have this happen, that's why it would hurt, because this rubber band has been put through so much stress, it's elastic, that it's going to have a reaction, an energy reaction, that when it breaks, it's going to release all that energy at the break in all directions and push that rubber band to travel at a speed that is so much faster than the stress I'm putting onto it, okay, to try to return it to its original form. So rocks in the earth go through the same type of elastic rebound. They when they are pushed and pulled and bent and buckled, then they come back to they try to put themselves back to their actual form, they break, and they release an immense amount of energy. Well, that immense amount of energy causes the earth to move up and down, and that's what gives us an earthquake.